Try? Okay, maybe better.
1, 2, 3 testing. The one at the boiler listens into the chatter and simply turns the boiler on if any of the radiators calls for heat. So straight away, you're no longer heating bits you don't want. So for example, at me at home, our main old mechanical valve is sitting in the lounge where the family is most of the time. That's fine. But if I want to work at my desk at the other end of the house, I used to have to keep the lounge warm to get my room warm. Now I just have one of these sitting beside me on the desk, and instantly I can take it with me to where I am in the room. So it's that part of the room that gets hot, and when I need heat, the boiler comes on, or when I don't, it's not on. And there's a lot of evidence, basically, that this sort of zoning will halve your energy consumption. But we've also got in here occupancy sensing. It's very simple at the moment, but it's there's nothing smart about our technology, I promise you. But simply, if the room is too dark for you to be doing anything, it drops the target temperature by a degree and stuff like that. There are no clocks. You'll see there's no flashing 1200 on this. However, it does have a timer function. So for our kids, for example, when they go to bed at night, we want the room warm before they go up. And we used to simply go upstairs, turn up the valve half an hour early, and when they went to bed, turn it down. Now, we just put the thing on, press the learn button, and it will now every 24 hours heat the room for half an hour before they go to bed. No clocks to program or anything. It all just works. And we're aiming for one of these to cost a tenner a unit retail. Now, picking some numbers pulled, as all the good stats are, made up on the spot. But there's something like this in wasted energy consumption in the UK. And furthermore, the domestic energy consumption is responsible for 20% for heating, is responsible for 20% of the UK's entire carbon footprint. So we could be talking about knocking 10% off the UK's entire carbon footprint for a tenner a house with no other changes. Now, of course, those work in conjunction with better insulation and all of those things as well, but ours is a dead cheap change. And the important thing is that you can fit this yourself. You don't need a plumber or an electrician. So it's meant for retrofit because most of our current housing stock will still be standing in 2050. Right. So what do we do? What's the smart bit? It's zoning, occupancy sensing, anticipation. In fact, we're doing a trial, very small trial at the moment, and that's all turned off. But all of that sitting in here, it's Arduino based. In fact, we have a pickaxe one as well. Cheap. At the moment, for the prototypes, this combination costs, with some time for love added in, probably 100 quid a shot. Okay. But in practice, the aim is to get that down to a tenner retail. Why do I believe it? Well, the people who make this make a programmable valve which does all of this except the radio for 10 euros. So I'm pretty convinced that if we were to go back to the same people and say, build one of those, please, then they could do it for £10. You'll notice a slight slip on exchange right there. It's designed to be simple, so I feel slightly embarrassed being the IoT and admitting we don't actually do the I bit at the moment. And the connecting homes was funny as well because it's called connected homes, and almost all the winners didn't have any connection to anything. So you don't need any internet connectivity, but of course we're hoping this is also aimed at people like my in-laws who don't have any internet at all. It's not an option for them. They don't want it. But we can certainly on the hub put connectivity into the net. And all the stuff is meant to be interoperable to keep costs down for end users. And so they don't end up with stranded assets. You buy a nice big Honeywell system and then you think, oh, I like the thing from X, and you have to throw away your Honeywell system. So easy to use. Well, our project manager's 4-year-old can operate it. And indeed, my 5-year-old can operate it. So I think even I may be able to manage it. Typical house, 5 radiators to control. A tenner for each of these units, the all-in-one unit. So when these two are in one box. And a controller. So we've got change out of 100 quid. Can be done by the end user themselves. Everything open source, as liberal as we can make it. And this is open in the sense of we want the code to be used as widely as possible. And we don't want manufacturers to feel constrained about how they use it. So Apache and solder pad for the circuit diagrams and so on. And the box design. So we've been playing with 3D printing. That's been quite fun as well. current state, so there's probably 6 active contributors or something, some of people here today also. And mailing lists, documentation, we have an IRC chat regularly, we've got lots of websites up, 3D box design, some of them in Thingiverse. Here was the Thames Valley RepRap group were at a maker fair and we got them to make 50 boxes for us, which is rather nice. And here is our project manager's daughter actually assembling one of these things as well. We use child labour in our projects. Oh, sorry, are we not meant to use child labour? I can never remember. And it's quite, heartening. We get lots of interest from people in the Netherlands saying, can we possibly control our university dorms with your system? I said, well, not quite yet, not till we've tested a bit more. We won a prize in connecting homes, which is nice. We entered a hackathon. Martin and John here were helping out. Had to simplify our proposition and threw away the wrong half of the proposition, unfortunately, so we didn't win that one. Engaging with energy retailers, one way of getting this out the door. Energy retailers can't just go on making money by selling more energy these days. They've got to decouple, they've got to sell services, they've got to sell more sizzle and less sausage. So Connecting Homes is a British Gas thing where they're trying to sell you a service which is saving energy, even though it apparently cannibalizes their primary sale to you of the gas. So we've spoken to them and they said that's very interesting, come back when it's all done and there's no risk, but that's what you expect a big company to say. We went to one of the green suppliers and they say, yes, we'll help you, and if you want money, that's not a problem. So that's nice. We're doing a very small university trial at the moment. It was going to be bigger, but anyway, it's running now. And engaging with government, we've been told we're in a climate kick accelerator program, so that's, well, I haven't told this yet, but I think it's 20,000 euros to start with and going up. So all very positive so far. Things in the future, trials, yes, Internet of Things, here you see, concession to the actual topic. And I have my first smartphone. I've been on an ancient communicator, so I can actually do some development against my own smartphone soon. Thing coming up, one issue is that the protocols that are currently used tend to be proprietary, or they tend to be completely insecure. And we'd like to have, without inventing yet another standard, have something which is both secure, and the new versions of the radio chips, which are cheapest chips, that have AES and stuff built into them, it ought to be possible to come up with something which is lightweight enough for the Arduino, the AVR to manage, for example, is wrapped up in decent security, is open, and is, say, easily compatible or translatable to MQTT or one of these other low-level existing protocols, so that it's, if you like, just another binary representation. And the other thing is that when you're writing protocols to be used on low-power devices, which may even be doing energy harvesting, you have to be exceptionally careful how you do it. For example, this thing only listens for 1 second in every 2 minutes to keep its duty cycle on its radio low, which requires an interesting synchronization protocol. So at the moment we're using this commercial device. We hope to maintain a split version like this, because this is jolly nice to carry this around the room with you and have the temperature follow you, but that will probably cost twice as much as the fully integrated one where it just goes on the radiator where you'd normally expect. We want to keep hobbyist DIY stuff there, so it's easy for people to hack their own. And if you look at our last slide, you'll see, we're after sort of lawyering help, although we had some more last night in the Grand Place, where one normally goes to get free lawyer help. And we're all geeks, and so industrial design is not something design. I've heard about it. So that's us. I've got some sample stuff here. I've got lots of stickers. That's the most important thing. I've got some box prototypes. This is a real design. I can take the front off. There's a little bit of archaeology here. So if I hold this up carefully, the very top one on the Vero board was the very first one I wired up, and that was still actually controlling my boiler until about a month ago, and I replaced it with a slightly less flaky one. And that's Pickaxe. And I don't know if you know Pickaxe, but it's a basic interpreter. It's got space for about 2,000 statements. And it's enough. It's actually enough to do the whole job. Below it on the left is we did our first PCB with a Pickaxe. So there's an SMD device. And then over here was our first revision board with the AVR on it. Now the AVR has oodles more space, and also I can or I need to write direct machine instructions, which is jolly nice. This is our Rev 1 board, and we hope to, and I can open it up if anyone cares, and I hope to get another revision out with some improvements from user feedback in the next month or so. Any questions? So your question is, do I have a technical... okay.
I'm looking for a overall technical perspective of how all these different modules plug together, and from a technical point of view.
I think you've discovered what we call an oversight. I've forgotten to put such a thing in. It's dead easy. Every radiator is controlled locally, as you would just if you had an electronic radiator valve, just to keep the room level. And the only special thing we've done here, it's what us in engineering would obviously call a hack, a filthy hack in fact, is that the thing at the boiler just eavesdrops on the conversation. If any radiator valve is open, switches the boiler on. Now, we'll have a more sophisticated topology, but the whole thing is currently done by eavesdropping. I'm expecting NSA, to turn up at any moment and ask for advice. But that's all it is. It's a filthy hack, and it works. Now, the hack was even filthier originally, that on the pickaxe I couldn't actually pick up using this wireless chip. I couldn't actually read the data. So all I did was that when I opened the valve up enough and I transmitted, I put an extra header on the front of this that the valve ignored, but this could see. And when I got sync on that extra header, turned the boiler on. So now I'm a little bit more grown up, and I actually decode the data and make sure it's what we expect inside as well. So.
So one of the in countries like the Netherlands, one of the holy grails there is to be able to also like modulate your boiler to not just sort of like, well, now two of them want it on, but actually how fast do they want it on, and what's their expected load, or how can I pre-modulate? Is that something in your plans?
So at the moment we're just a bang on-off controller. Actually, for example, simple boilers such as mine at home look at the flow and return temperature and internally modulate. So in a sense, I'm kind of avoiding the issue. In theory, we'd like to talk OpenTRV or something like that, but OpenTRV ain't that open, and no one seems to follow the standards. Yes, it would be nice to do, but I think we need to get the basic thing working first, and smarter boilers hopefully will do things like weather compensation and internal modulation. But yeah, like to do it. Not there at the moment.
I'll just add one word on this. The whole design is also meant to be, as we say, so you can retrofit on existing systems, and it works at my place with an 18-year-old boiler, so which I should replace really, but it works. Yeah, but it still works.
Sorry.
Thanks. Just a very quick question. At the moment, the thing at the radiator is only sending information out. Can you send back to it to say, I want to change, so I could remotely change the policy for that room?
So at the moment, the answer is no, because I want to keep it as simple and cheap as possible. You're not the first person to ask the question. If we had integrated with British Gas's thing, we would almost certainly have put a Zigbee thing inside this, although there aren't many controls you can see. There's a developer's control, which is an FTDI cable, and it's got a CLI behind it. So in fact, either routed over the normal radio or routed over an alternative radio, that's ripe for connection and control by a central hub. Now indeed, Bruno was suggesting we could do things like, the problem I was saying about when you're trying to conserve energy, you want very low duty cycle on your radio, so you've got a kind of synchronization problem. But the nice thing, of course, is once you've synchronized, as soon as you've received a packet, you can transmit one as well. So we're thinking about it, and if we do a central hub which allows you to control, that will be a feature of it, and we have some ways how we might go about it. I don't think it's a huge problem, it just needs thinking about. And in particular, I wanted to make these as dumb as possible so they couldn't be hacked. So if we're going to allow this to be controlled remotely, I'm only going to do it when I'm happy that our level of security is such that in a bored tower block, in a tower block full of bored teenagers, they can't be hacking the heating of the people on the 3rd and 4th floor, all right? So, that will determine when I feel that we can have the remote control on that. That's my opinion. I'm only one in the group, of course, but that would be my view. Do you want to?
Two questions. One on hacking. Is your protocol resistant to packet injection? And secondly, at my place, the heating, the button is, the regulator is very hard to turn. So I'm wondering, do you have like, what's the system you put on it, and what's the, if there is one, what's the coupling force you have to apply to it?
Having not seen your house, I'm going to have to make a guess on the second one of those. The first one is at the moment, I mentioned the term filthy hack a few times. So this isn't actually our protocol. I wanted to go to the GNU radio talk because actually one of our collaborators went and reverse engineered the protocol on this. And I did actually write to the company who did EQ3 and said, can we use your protocol officially? And they said no. So I'm doing so unofficially. So it's not our protocol, and it has no security at all. Now, this isn't generally a problem. People aren't generally hacking home heating systems.
So I'm going to be very, very rude, and I'm going to suggest that we move this to the unconference format. That's not you're going to stop talking. We have more questions for Damon, right? Okay. So, and we want to keep you talking. First of all, thank you for the presentation, the demo. So I'm going to propose, we won't even take a break, we'll just carry on. So we're going to empty this row if that's possible. If you could move away from that row.